So let's say we're setting up a brand new laboratory and we're trying to have it be a really high precision environment where we can give really good quality results to people. So you're setting it all up. First thing you have to do is decide what gear are you going to buy? Because obviously if you buy garbage gear, you're not going to have very good precision. If you buy pretty good gear, you're going to manage to have a good balance between the cash you spend and how good quality the result is. You can spend a total crazy amount of money and try to get some sort of a NIST quality lab that gives really high precision measurements all the time, but you may not actually care about that degree of precision on a daily basis. Certainly not with the associated price tag. So there's going to be some trade-off for that. That's the first decision we got to make, and that's the thing that's probably going to have the smallest error to it. The next thing we're going to have to decide, who are we going to hire? Do we have the right laboratory hands to actually do good quality measurements? This is probably going to be a bigger effect than the gear itself. Obviously, if you have really good quality gear, anything that you see on top of that is probably based on our hands. Now, we see that in our lab all the time. Our analytical balances are going to have some error to them, but the gear is good enough that it's not going to have significant error beyond the decimal places that it's showing. It's showing a good quality measurement, and it's actually got more precision that it's hiding in tailing off values that it just doesn't display. It's just showing us the ones that it can be very confident about. But then we get in, and it's a question of how well were we handling everything, were our transfers really good, that sort of a thing. Okay, but that's not just a question of how good one person's hands are. How good is the lab's set of hands, and how much does it matter when it's Monday? You've always heard probably that you're never supposed to buy a car that was manufactured on Monday because since everyone was off on the weekend, that one's going to be garbage. I'm not so sure about that, but you kind of see the logic to it, and you can picture the same sort of logic in a lab environment. Day of the week might have an impact, and the people doing it may all have slightly different skill levels that give some differences in reproducibility. If you watch the video that we have on our quality control spreadsheets and our analysis, you probably remember that I pointed out that different semesters had very different measurements. And that kind of gets us to a fourth idea too. How well is one lab versus another? That could be an East Coast, West Coast thing. That could be a up the hall, down the hall kind of thing. That could be a semester to semester thing. But this is going to be how reproducible measurements are based on each measurement. Now let's actually expand it to be the proper terms. The quality of our gear, that goes to what's called instrument, or sometimes it's called injection precision. And the idea is basically that most of the time you have an instrument that has to, not most of the time, many times you'll have an instrument that has to inject a sample into itself. This lets you test to see how well that's done. Even more instruments don't have injections, and so usually we call it instrument precision, but you'll see them used interchangeably. The next thing, hands. It's not just, precision is not just going to be a question of how good your instrument was. Most of the time you were preparing it. I mentioned your analytical balance is probably going to have more precision than the way you actually set up your samples yourself. We call this intra-assay precision. And intra-assay precision is just basically saying, hey, one guy standing there doing it on a certain day with the same gear throughout, if they do lots of measurements, they're probably going to see that they're not going to have a totally reproducible set of measurements. You saw that. You've actually seen this before. This occurred during the very first experiment of the semester. Remember that we filled up our our volumetric flask. We took some water out. We filled it back up to the line, took some out, filled it back up to the line, and each time we were taking a mass of it. And from that, you're able to get a standard deviation on that glassware. Remember that the glassware was made to a higher precision, in other words, an instrument precision, than our hands were able to return. So there's an example that you've already seen of our instrument precision versus our intra-assay precision. Now, if you were to come back on a different day and do the exact same thing, you might get a different result. That's called ruggedness. Basically, you get the same result whenever you do it. And the result of our interlab is reproducibility. So reproducibility, basically just saying, if you go to a different lab and have the exact same thing done, do you get the same result? So in my experience, at least, this tends to be very small. This is the big question mark. This one can be controlled, but often uncovers some issues within a lab, and that can often be hardware based. Not just that you don't have the right people. It's not just that they're screwing up. It might be that you're getting an inconsistent supply of chemicals from a company. It could be that the elevator working on certain days creates power spikes that ends up messing with one of your detectors. It could be that the ultrasonic microphone on the ceiling that sees if people are in the room and turns off the lights is being picked up by the ultrasonic microphone and you didn't realize it. Not that that's ever happened to me. These are the sort of things that go toward ruggedness, and they can be small effects once controlled, but until you identify them all, these can be so giant that you're unable to do any work, crude or otherwise. That bit me pretty hard, that my instrument ended up being very non-rugged because of that ultrasonic microphone thing. And also there's that intralab reproducibility. This can be a big difference. This is going to be a much bigger one typically than the instrument precision. But it is one that can be controlled for, and by testing carefully you can make sure your lab gives consistent results with other labs.